Hi students, this is Dr. Davis just giving you a video for Unit 8 as it relates to substitution, elimination, and of course graphing. So let's begin. Substitution is the idea of substituting one particular line, for example, y equals 6x minus 11, in for y in the next sentence. So I just want to make sure we all understand why we're doing substitution. The main goal for substitution, elimination, and graphing is to find a singular coordinate pair that has an x and a y that solves the system of equations. Okay? So for number one, let's go ahead and get started. It says y equals 6x minus 11 and negative 2x minus 3y equals negative 7. What I'm going to do, I'm going to input this 6x minus 11. I'm going to input it in for this y. This is what it looks like. Negative 2x minus 3 in parentheses. 1 minute, let me just increase my screen. Negative 2x negative 2x minus 3. In for y, we're going to put that 6x minus 11. And that equals negative 7. Pardon, my computer's acting a little slow today. Alright, so if we combine it all together, we now have negative 2x. Negative 3 times 6x is negative 18x. Negative 3 times negative 11 is plus 33. That equals negative 7. Then if you combine like terms, you get negative 20x plus 33 equals negative 7. If you move the 33 to the right, you have negative 20x plus 33. The minus 33 is moving it to the other side, so negative 7 minus 33. The 33's cancel, 33 minus 33. So then you have negative 20x equals negative 7 and negative 33, same signs you add, you get negative 40. And then, if we divide by negative 20 on both sides, on this side, two negatives make a positive. 20 divided by 20 is 1. Altogether, we get just x. Negative 40 divided by negative 20, again, two negatives make a positive. 40 divided by 20 is just 2. And we did all of that work just to find an x. And this is still problem number 1. All right, let's keep going. So now that we found x, we can input x into either equation 1 or 2 to find a y. I always like to input the x value in the easiest equation possible so I can get a y quickly. And that will be the first line. So y equals 6x minus 11. If x is 2, we have 6 times 2 minus 11. This is the same as 12 minus 11, which is just 1. What that says is our coordinate pair is, in this case, 2, 1. Now, how would you know if you did it correctly? Well, I will show you a check step. This is the check step. You would input 2 and 1 for both equations to make sure it works. So, of course, y is 1, and that's for this first equation. If y is 1, that equals 6 times 2 minus 11. Is 12 minus 11 1? It is. So you can say it works here. Now, what about for the next equation? For the next equation, we have negative 2, x is 2, minus 3, y is 1. Is that the same as negative 7? Well, negative 2 and 2 is negative 4, and a negative 3 is negative 7. So it works here. In order for it to be a solution, In the check step, it has to work for both equations. Okay, any questions up to this point? Just want to make sure I'm not going too fast on this. At the same token, I want to make sure I'm covering as much as possible so it can help you on your practice problems. All right, if there are no other questions, let's keep going. 2x, and this is number 2, minus 3y equals negative 1. And of course, y equals x minus 1. All right, so in for this y, I'm going to input x minus 1. So now we have 2x minus 3 times in for y, we have x minus 1. That equals negative 1. Then we apply the distributive property for negative 3 inside of the parentheses, and we have 2x minus 3x. And negative 3 times negative 1 is plus 3. That equals negative 1. So 2x minus 3x, if we combine like terms, is negative 1x plus 3. That equals negative 1. Then we want to move that 3 to the other side. So we have negative 1x plus 3 minus 3 equals negative 1 minus 3. In this area, 3 minus 3 is 0, or it cancels out. So we now have negative 1x equals negative 4. If we divide both sides by negative 1, we have negative 1x divided by negative 1. That equals negative 4 divided by negative 1. On both sides, two negatives make a positive. So we have x equals, so two negatives make a positive here and here. And then negative 4 divided by negative 1, since it's positive now, it would be a positive 4. Positive 4, okay? And using the same concept of inputting x into the easiest equation, you can also choose the other equation, but I always choose the easiest one. So it's y equals x minus 1. The question is, what is 4 minus 1? And 4 comes from here. What is 4 minus 1? 4 minus 1 is just 3. So your coordinate pair is 4, 3. Okay? And then you can do the check step on your own, so that way you'll be able to make sure that it checks out. But other than that, if you have questions or concerns on how I set this problem up, feel free to reference this problem in an email to me, and I'd be happy to give you further clarification. All right, let's go on to number 3. We have y equals negative 3x plus 5 and 5x minus 4y equals negative 3. In for this y, I'm going to input negative 3x plus 5. So we have 5x minus 4 times negative 3x plus 5, and that equals negative 3. So 5x minus 4 times negative 3x plus 5 equals negative 3. All right. Still using the distributive property where it relates to negative 4 and everything else inside the parentheses. We now have 5x. Negative 4 times negative 3, two negatives make a positive 12x. And then negative 4 times 5 is negative 20, and that equals negative 3. If we combine like terms with 5x and 12x, we get 17x minus 20 equals negative 3. We need to move that 20 to the other side. So we have 17x minus 20 plus 20. That equals negative 3 plus 20. So we have two negatives make a 2. In this area, two negatives did make a positive. But now here we have 20 minus 20. That cancels. We're left with 17x. 20 minus 3 on the right-hand side is just 17. And of course, 17x divided by itself . 17 divided by 17 is x. 17 divided by 17 is just 1. All right, so our first x is 1 as it relates to problem number 3. So, going back to my original theory, I always put the x into the easiest equation possible. So y equals negative 3x plus 5. So you have negative 3 times 1 plus 5. This is the same as negative 3 times 1 is negative 3 plus 5. Negative 3 plus 5 is the same as 2. Your final answer in this area would be 1, 2. And you're welcome to check your work as you need to, just to make sure that when you submit it as far as your homework, even as you go through your practice homework, please do that check step, because that's the one way you'll know that it's correct. And for your Dropbox homework, please do the check step as well, so that way you'll know before you submit it to me if it is correct. All right, let's keep moving. We've done substitution. Now, let's do elimination. Elimination is the idea of eliminating a single variable and then combining the rest of the terms. Let me show you what that looks like. For this particular problem, we have negative 4x minus 2y equals negative 12, and 4x plus 8y equals negative 24. As you look at x's and y's, which are the easiest to eliminate? Well, when I look at x's, negative 4x and positive 4x is 0. So that's an automatic cancellation. So I have eliminated the x variables. Now, what I need to do is combine everything else. 8y minus 2y is 6y. 8y minus 2y is 6y. And then negative 12 and negative 24 is the same as negative 36. So if 6y equals negative 36, and I divide by 6 on both sides, I get y equals negative 6. So if I get y equals negative 6, I got to plug it into either equation to get an x. So I'll try the bottom equation. And I'll say 4x plus 8y equals negative 24. So we have 4x plus 8 times y is negative 6 equals negative 24. So now we're going to combine as much as we can in order to get to x equals. So we bring down 4x. 8 times negative 6 is negative 48. That equals negative 24. So we have 4x minus 48. We want to move that negative 48 to the other side, so we're going to do it by adding 48. That equals negative 24 plus 48. Here, 48 minus 48 is 0, so we have 4x equals, and then on the right side, 48 minus 24 is just 24. If we divide 4x by 4 and 24 by 4, we get a final answer of x equals 6. And of course, you can do the check step on this as you like, just to make sure that you got the correct answer. So your final answer is 6, negative 6. That's your coordinate pair for this situation. Okay? Any questions on how I did this problem, on how I decided what to eliminate? Don't get me wrong, all the problems may not come out as easy as this one. So I want to make sure I'm doing some problems that look a little bit different from what we've seen before. All right, if there are no other questions, let's keep going. Let's try number 5. Number 5, it says negative 2x minus 9y equals negative 25. And negative 4x minus 9y equals negative 23. Now, you can look at this two different ways. In terms of the x's, if you decided to eliminate the x's, you would need to multiply the top by a negative 2. Your question would be, why are we multiplying by negative 2? because negative 2 times negative 2 is a positive 4. Positive 4 minus 4 eliminates x's. Okay? That's one idea. If you wanted to eliminate the x's. If you wanted to eliminate the y's, you notice you have negative 9y and negative 9y. You can multiply either the top equation or the bottom equation by negative 1. Your question would be, why are we multiplying by negative 1? Because negative 1 times negative 9 is positive 9. Positive 9 minus 9 is just 0, which eliminates the y's. Okay? So, let's go ahead and do that. So, let's use negative 1. So we have negative 1 times negative 2x is just 2x. Negative 1 times negative 9y is just 9y. And that equals negative 1 times negative 25 equals 25. And then bring down negative 4x minus 9y equals negative 23. Draw a line underneath it, because now we're going to either combine or eliminate. Our y's eliminate. 9 minus 9 is 0. Next line. Negative 4x plus 2x is negative 2x. That equals, remember the y's are canceled, 25 minus 23 is just 2. So, negative 2x divided by negative 2 equals 2 divided by negative 2. On the left side, 2 negatives make a positive. The x's cancel, the 2's cancel, I'm sorry. The negative 2 divided by negative 2 is just 1. You're left with x. And that equals 2 divided by negative 2 is just negative 1. Okay, so we have found our x value. We have not found our y value. So, I'm looking at this equation here. And I'm going to say negative 4x minus 9y equals negative 23. So we have negative 4 times negative 1 minus 9y equals negative 23. Negative 4 times negative 1 is 4 minus 9y equals negative 23. I want to move that 4 to the other side. So I need to say 4 minus 4 minus 9y equals negative 23 minus 4. On the left side, 4 minus 4 cancels. We're left with negative 9y equals negative 27. If I divide by negative 9 on both sides, so I have negative 9y divided by negative 9, that equals negative 27 divided by negative 9. 2 negatives make a positive on both sides. Our 9's on the left side cancels. We're left with just y equals. On the right side, 2 negatives make a positive. 27 divided by 9 is just 3. Your final coordinate pair is negative 1, comma 3. Feel free to do the check step on this if you need to, because that will help you as you're going forward. Because oftentimes we think that once we're done with the problem, this is just the answer. Well, we have to make sure that we do the check step for every single problem, because that way we will know whether we have done it correctly or not. Okay? I think we got time for one more problem. Let's do number 3. X minus y equals 11. 2x plus y equals 19. Alright? What is the easiest to eliminate? Look at the x's. There's a 1x and a 2x. And then we have a negative 1y and a positive 1y. Which is the easiest to eliminate? Feel free to go ahead of me if you like. Alright, I'm going to cancel the y's, because that will be the easiest option. When I cancel the y's, 1x plus 2x is 3x. That equals 11 plus 19 is 30. Okay? 3x divided by 3 is the same as 30 divided by 3. So 3x divided by 3 is x. 30 divided by 3 is 10. So this is one of the problems that we initially started out with. Okay? So if we have x is 10, well, I'm going to input it into this second equation. So that would be 2x plus y equals 19. So we have 2 times 10 plus y. Remember, we're still trying to find out what is y. That equals 19. 2x, or 2 times 10, is 20. Plus y, that would also equal 19. Please be careful with your signs in these areas as well, because it's very, very easy to leave them off. So if 20 plus y is 19, we need to subtract 20. So 20 minus 20 plus y equals 19 minus 20. 20 minus 20 is eliminated, or canceled. So y equals negative 1. Our final coordinate pair is 10 and negative 1. Any questions or concerns on this? Questions or concerns? If not, I just want to do a beeline into solving systems of equations by graphing. My recommendation for solving these type of systems of equations is to either do substitution or elimination, because for that problem, if you do either substitution or elimination, you will find the intersection point. You will find the intersection point. What you will need to do is use your x and y chart in order to find the x's and the y's. And we're going to do an example of that in just a second. Alright, so we have negative 5/3 x plus 3. This is x, and this is y. Okay? When you're dealing with fractions, look at the denominator, and these are the multiples of the forms that you will need to have in order to find your x's. When I say multiples, I'm looking at 3 and I'm saying 3, 6, 9, so on and so forth. Okay? I always use 0 as an x. So 0 is always an easy x. So negative 5/3 times 0 is just 0. 0 plus 3 is just 3. Okay? Ooh. Next, I want to use 3, because 3 is a multiple of itself. Negative 5/3 times 3 over 1. The 3's cancel. The 3's cancel. So you have negative 5 plus 3 is negative 2. Okay, so you got the 2 points for that one. Now, 1/3 x minus 3. Now we have x and y. And this is your x and y chart. So of course 0, we love 0 so much that we just use it all the time for our x's. So at 0, 1/3 times 0 is just 0. 0 minus 3 is negative 3. Okay. It keeps doing that to my indent. Okay, and since 3 is a multiple of itself, we can use 3 again. 1/3 times 3 over 1. The 3's cancel. We're left with 1 minus 3. 1 minus 3 is negative 2. Okay? So your question would be, okay, when I draw my graph on here with the straight edge, what does it look like? Oh joy. Well, I happen to have a graph here. Okay? Let me stretch it out a little bit. First question, or first equation is y equals, in parentheses, negative 5/3 x plus 3. And this is a Desmos calculator, so you can use this definitely for your problems. So that's our first line. Our second line was 1/3 x minus 3. Y equals 1/3 x minus 3. So based on these points that we would graph, you see 0, 3 is here. 3, negative 2 is here. 0, negative 3 is here as well. And 3, negative 2. You notice 3, negative 2 shows up twice. That is your intersection point for this problem. Okay? All right, let's do another one. Let's do number 2. I'll leave the X and Y charts there. Of course, I want to use 0 for each and every row. But we're going to change the problem. So we have 4x plus 3. And we have negative x minus 2. All right. So let's look at 0 and 1. These are just random points. 0 and 1. All right. 4 times 0 is just 0. 0 plus 3 is just 3. 4 times 1 is 4. 4 plus 3 is 7. Okay. Same axis. Negative 0. There is no such thing as negative 0. So it turns out to be just 0. Minus 2 is negative 2. And negative 1 and a negative 2. Same signs. Negative 1 plus negative 2 is a negative 3. Okay. Now let's put this in our Desmos calculator. Let's see here. Y equals 4x plus 3. And negative y equals negative x minus 2. All right, let's see where we're going. Did I put it in correctly? 4x plus 3 and negative x minus 2. Okay. At 0, we're at 3. At 1, we're all the way up. 1, 2, 3, 4, 5, 6, 7. At 0, we're at negative 2. And at 1, we're at negative 3. Our intersection point is at negative 1, negative 1. Okay? So just a way to look at it in terms of an actual calculator. What is it going to look like when I graph it? Okay? Let's put another problem in there. Y equals negative 1. So y equals negative 1. And y equals negative 5 halves, negative 5 halves x plus 4. Okay. Let's look at this intersection point. Let's see here. Our intersection point in this instance, from this line, remember this is y equals negative 1. This is the y equals negative 5 halves x plus 4. Our intersection point here is 2, negative 1. 2, negative 1. Okay. Let's see. Do we have another one here? Let's do this one. Negative 2x plus 2. Y equals negative 2x plus 2. And y equals negative 2x minus 2. Oh. Now what happens here? You notice there is no intersection point. No intersection point. Why? Because these are parallel lines. Parallel lines do not have an intersection point because they never meet. They never touch. So in this instance, you would say no solution, or you could also say parallel lines. So this is just a brief review for Unit 8 and the material you'll be covering. I just want to make sure that everybody's clear and there are no questions or concerns throughout this time. But if there are, feel free to email me and let me know. If you have any questions, feel free to reach out to me.